Welcome back. In this lesson, we're going to talk about glaciers. And glaciers are rare on Earth, but the glaciers that we do have are extremely impressive. There is so much ice, and this ice is moving, even though it's moving very slowly as it falls down a mountain. It can do incredible damage to the ground and cause its own features, topographical features, that we'll look at together. A glacier is an enormous block of ice. It normally has formed over an extended period of time when snow is accumulating faster than it can melt. So if you were to have an extended, like a very high elevation where the temperatures are very cold, and if you have any precipitation at all, it's normally snow, you can have glaciers. Many of the valleys in the Alps have or have had glaciers, some in the Rockies. The very high mountains in the Andes all have glaciers. There are also glaciers in the extreme north and south of the globe, so Greenland and the Arctic circles and Antarctic areas. So the whole continent of Antarctica is covered with ice sheets. Most of the North Pole, which actually the North Pole itself is over water, that is normally frozen. As the temperatures rise, you're going to have differences in that, and glaciers are melting at extreme rates right now. But when you do have a glacier, it is still subject to gravity. Even though it's enormous, it is still going to be running downhill. Glaciers run very, very slowly. So as it runs, it's scraping like a bulldozer as it is going down the hill and out into a valley or wherever it happens to be. So you have two types of glaciers. You have continental glaciers, of course, very large, extended areas over whole plains, and then valley glaciers. And the valley glacier is normally coming down a mountain and into a valley, carving that valley perhaps, and then filling that valley with ice. So let's look at valley glaciers first. So they are mountain glaciers. So when the ice is heavy, it's going to, first of all, it's locked together. So it's not like water, where water could be conceived of as a block or could be conceived of as individual molecules. This ice is together, so it's going to move together. Now it is plastic of sorts. It can change shape, it can stretch a little bit, but ice, huge blocks of ice, is acting as one whole thing. And so as it's falling down the mountain slope, it's carving as it goes. Normally you can tell that there's been glacier activity if the valley has a U shape. Normally a V-shaped valley is going to be water. Water is carving down faster than it carves the sides. The continental or a glacier is carving the sides and the bottom at the same rate as it's scraping its way by, and so you normally have a distinctive shape. So continental glaciers are, much of these are in the high north, high south. So we're talking about Antarctica as a continental glacier. The entire continent of Antarctica is covered in a glacier and even sticking over the edges. And then Greenland, much of Greenland is also covered with a continental glacier. So as these glaciers move, they are going to carve certain erosion features that can be very distinctive. Okay, one is called the horn. So a horn is this jagged top to a mountain that where there was once the edge of a glacier, and as it grinds down, it's going to file away that mountain, so it becomes a serrated type of mountain. You can also have cirques, and you can see kind of the word circle there, kind of Frenchified circle, and so you're going to have an area kind of in a little bit of a valley there, or a hollow in the high mountain, where that's the round edge of a glacier that as it scrapes, it's going to create these round things. Let me see if I can go further down. Okay, so a cirque is that bowl that was formed from the upper edge of a glacier. Now, an arete is not just remember, a horn is the peak, and it's a serrated peak caused by the edge of a glacier. If that peak, instead of one peak of a mountain, you end up with an entire ridge that is sharp like a knife on one side, that's called an arete. Okay, and a hanging valley is you've got a small bowl that is then joined to a larger area scraped by a glacier. Okay, so you could have a one valley that then falls off into a larger glacier. So as you end up with smaller area at the top of the mountain and then a larger area at the bottom of the mountain, sometimes you end up with kind of like a huge glacier waterfall. That's a hanging valley. Now, the deposition is like a bulldozer, because a glacier is one solid piece, and so as it's scraping, it has all of that force behind it. It can literally move mountains. Okay, so you're going to get very distinctive shapes of ground left over by these glaciers, either the grinding or the edges or something doing with the washing of the water. Okay, so first of all, let's look at the moraines. The last part of that glacier is pushing rocks ahead of it, and that rocks, if it doesn't go any farther, then that is called the terminal moraine. So that terminal is the very edge of where that glacier was when it was as far as it went. Okay, so that it's pushing to its extreme, and then once it's pushing to its extreme, it leaves gravel in front, and these gravel can be as big as hills, and these are called moraines. Okay, you can also have little perpendicular little smaller hills that are coming off called drumlands, and drumlands are going to be perpendicular to moraines, and then you can have dips called cames. So let me define a few of these for you. So the drumlands, you're scraping the ground, and so as it scrapes, you're going to have let's say there's a moraine in front of a glacier, and the glacier is keeping on moving. It'll grind over that glacier. It'll push most of it ahead, but grind over some of it. And as it does, it will line it up vertically in the same direction that glacier is moving, and that's called a drumlin. Okay. Eskers, so winding ridges of layered sediment from streams. So you're going to have ice that's melting at the surface of the ground. So there's going to be water under the glacier that then escapes, and water runs faster than the glacier, and so you're going to get streams coming from this glacier. You're even going to have some ponds and some lakes caused by this melting streams. So the layered streams, the streams can cause these sediments to pile up, and these ridges are called eskers. So it is this loose sediment from the glacier that's actually caused by running water. And then cames are mounds. So as the glacier recedes, some piles up into mounds, these are called cames, and some scrapes into long stripy hills, and those are called drumlins. And then the last thing is lakes. So any of these carvings can now be lower than the surrounding valleys, and then that can fill up with glacier water and form glacial lakes. Especially if you were to have a lake that could then be stocked by some kind of a spring, you could have a long-term glacial lake. And some of the most beautiful lakes in any of the mountainous regions are going to be glacial.